Today's lesson is focusing on the use of the Pythagorean theorem. And the Pythagorean theorem is a squared plus b squared is equal to c squared. And the Pythagorean theorem, visually representing that, has to do with right triangles. So I'm just going to draw myself a typical triangle. And I'll be sure to make sure that one of the side lengths, that two sides actually create a right angle. That square means that's a right angle. So this right here, this side is called a leg, and this side is also called a leg. And I always say that the legs are actually the sides that join together, and they actually make the right angle. So we got two legs, which kind of makes sense. Most people have two legs, right? Now the side that's across from the right angle, that's going to be this side. This is actually called the hypotenuse. And a key idea that you want to remember is that the side that is across from the right angle, this is called your hypotenuse. And when you use the Pythagorean theorem, the hypotenuse is always your c side. So if I label this with the colors over here, I can go ahead and say that my a squared could be this one, or it could also be this one. So you can actually interchange. If this is A, this is B. Or if the first one is B, then the second one is A. It doesn't matter. Again, your legs can be interchanged. But what cannot be interchanged is your C value always has to be the hypotenuse. And with this diagram, you can kind of solve for the third or the missing side on any triangle. So now that we have our diagram, we're going to go ahead and use this notes to solve the problem over here. So the problem in Delta Math says find the side length of the third side. If necessary, round to the nearest tenth. So step number one, I'm going to ask that you draw the triangle and label the side lengths. Mark the unknown side with an A, B, or C. So again, let's start by drawing our triangle. It doesn't have to be perfect, but the majority of time I've noticed with kids, it's actually not the solving or the calculating, it's actually incorrectly labeling it. So I've got my right angle right here, and this is 17, and this is 25, and this is where I actually don't know what that is. Just for this example, I'm actually going to use the color coding. You don't have to. So let's see, the legs touch the right angle. So here's my right angle. So that's a leg, and this is a leg. And then we also notice from the diagram is that the side that's across from the right angle, so I'm going to draw my arrow over here, that's going to be green, that's going to be my hypotenuse. And again, you don't have to do the color coding, but I do want you to draw and label that. So now we got a couple choices. The yellow ones, those are our legs, and I have to use A or B. And so I can label that A, or I can label that B. And for right now, I'm going to call this one A, and I don't really need to put the variable here, but I'm going to call that one B, and then this one actually has to be C here. Again, notice that we have the color supporting it. So our B, our A, those are yellow, and then the green, that's our C value, which is that right there. Okay, so now that we have it drawn, and we have an A marked for the unknown side, we're just going to plug it into the Pythagorean theorem, which is a squared plus b squared is equal to c squared. And a is just going to be our unknown, so I'm going to put a squared plus, now my b value, I do have a length of that, so that's going to give us 17 squared, and then 25 will go into c. Then we're going to use a calculator. 17 squared is 17 times 17, and that's going to give me 289. 25 squared is 25 times 25, which is 625. And again, feel free to use a calculator for this if you need. So I have a squared plus 289 equals 625. I will use the subtraction property of equality. In other words, I'll subtract 289 on each side to isolate the variable a squared. And I now have a squared is equal to 336. Again, use a calculator if you need it. And then I'm just going to switch colors. To get rid of a square, you will square root both sides. Now I do want to point out that you can have a positive or a negative answer to this, but because we're talking about measurement's always positive, we're only worried about the principal root, which means we're looking for a positive value. So just to make sure you guys know how to do this, go into Delta Math, you're going to type in the square root symbol, and then you'll type 336, and that gives me approximately, now it's not a perfect square, That's going to give me 18 point, now the instructions say round to the nearest tenth, so I'm going to need 2 decimal places, 18.33. And please remember that that would actually go on forever. And this would be classified as an irrational number. But we're going to round, and when we round, we're going to put A is approximately equal to, it's like an equal sign that's been blowing in the wind, and this is going to round to 18.3. And so that's the answer. Now, just to remind yourself that this would be the 10th spot right here. And so I'd look to the right, and because that's a 3, I would round down. So 18.33 would round to 18.3. And let's make sure we box that. And so that's pretty much what you're going to do. Sometimes you'll get an answer that's a perfect square. So when you hit the square root symbol, it's just going to give you like 25 or 9. And then sometimes you'll get one that's a decimal and you'll have to do some rounding.